Hello and welcome to another video. Today we have a B450M Pro VDH2 from eBay. So I have no idea what is wrong with this board, but I can see one thing from the very get-go. What in the fuck is this? It's really hard to see, but someone has put this BIOS battery in the wrong way. I've never seen that before. I didn't even know you can wedge that thing in there the wrong way around. That is impressive. That is... wow. I just remembered I still have this exact main board that we fixed some time ago, where this controller was shorted, that controller was shorted, and that controller was shorted. All step-down converters. And I am very interested now what this board will do. So, can't be that bad twice, right? Right? So let's see. So let's take out 2200G. And let's now see what our passive power consumption is going to be. We have 100 milliamps. Okay. A little bit higher than I would expect it to be. But this could be fine. So the previous owner, I think, said that this got stuck on a CPU LED. So we have debug LEDs right here. And it goes from top to bottom, and the top one is the CPU one. So let's get a power button and the speaker onto here. And let's see how this board talks to us. What it does. So let's turn it on. Ooh, ooh. Holy moly. That just drove 5 amps and our VRM blew up. Whoo! Thank God I got that on camera. Holy moly. The cable actually got hot. Wow. Okay, well then. That just... I really don't want to take the heatsink off, to be honest. I don't want to look at what is there. Well. Should have checked voltage resistances first, right? Well, I would have thought that the previous owner had started this board multiple times before, but it seems like that they didn't. This is going to be interesting. I think we managed to save it early enough, because look at that. It isn't that charred. And let's go under the microscope and look at that MOSFET there. Beautiful burn through right here. This is part of the thermal pad that got stuck to it and burned. And it got so hot that the solder melted and squeezed out the bottom here. Very interesting. So we will have to desolder this whole face. So we will be desoldering these lower ones, the high side MOSFET and also the driver. Just to be sure. And then we will need to check these 2.2 ohm and this 1.5 ohm resistor, I think this is. And that's 0 ohm. And then check the resistance of the face again. But let's first clear everything out, because this is obviously bad. And for that to be easier, we're also going to be removing this capacitor right here. So we have easy access to remove all these components and replace them. So taking out capacitors like this is very easy if you have the right tool. So what I always do is I take a special knife tip that I have for my JBC station, which is this, let's see, this ginormous one. Can't even see, but it's a big blade. And what I just do, you need quite some solder, and then you want to heat both up at the same time and just wiggle at them, and it just falls out, just like that. And just like that, the capacitor is out without any problems. Now you can see our capacitor is out there, and this is our capacitor. And now we have free range to desolder this. I'm very interested now if this is coming off the board or not, or if we have to grind this off, and if we have layer burn through or not. So we're going to flux this area up good. So put some good flux everywhere. And now we will probably go around 400 degrees to desolder basically everything that we have here. We're going to keep the passive components for now. And we will certify that they work or don't work. But first, let's take the whole face off, like all of the MOSFETs, all three. And also the driver. And it stinks. It let out the magic smoke and holy moly, it stinks. So first MOSFET is removed. And it really wants to not let go of the layer. Let's see for the other one. We got the upper one removed. And also the controller, the driver is removed. Now let's see if we can pry off this burnt through MOSFET and leave as much of the actual pad of the 12 volts there. But it really welded itself on here. We might have to just cut it right here. So let's do that probably to not damage the board any further. Let's try to cut the big trace, because then we can keep the remaining phases here, like the remains of the phase right there. We can keep the gate and the output, and we will just have to put 12 volts under it again if we want to revive this phase. So let's see now if we can get a good cut into here. I will need tweezers as well to hold this. So we will hold this down, and with an X-Acto knife we will cut it completely off of here. And now we got it separated. And now we can take the whole MOSFET off together with the pad that was burned through, because it wasn't coming off of that. So what we can see now is this is below. This is the fiberglassing. It is a little bit charred, but it should be fine. There's nothing really under here. And what you also have, this is the 12 volts phase. As you can see, this is the big 12 volts coming everywhere. And this is also not burned, especially not under here, it's not. So this looks very nice, very good for us to be able to rework this area. We got really lucky with this burn, I think. So this is our output. This is going to be either SoC or VCore. I think this is VCore, and this is its gate. And that all of this is still good is very nice for us. So let's clean it up now to get a better look at it. I will be using cotton buds and a lot of IPA, and let's do that. So now our area is a lot cleaner. And now we can very well see the lower area with the low side MOSFETs looks very nice. And just our 12 volts here was burned through, but we will be able to rebuild that. That shouldn't be a problem right here, because this is a little bit burned, but it is still fine. Like we will be able to insulate this area down beneath here. We might want to get some of this burned glass off here, because this should be a different layer here, and we should be put solder mask then later on here if we want to bridge this to here, so we can solder MOSFET back onto all of this here. And then we will also have to put the driver on. But let's now go in the overview and see for our resistances. So let's see now for our 12 volts CPU. Do we still have a short? No, we do not have a short circuit anymore. That is very good to see. I'm very interested now in whatever this is down there. But that little bit of copper that we saw there, is that also 12 volts? Or is that ground? Oh, this might be still problematic. So, if we measure between 12 volts and ground, we get high resistance. And now, if we measure the 12 volts, we go to this capacitor, this should be 0. Basically, yeah, this is basically 0. Let's go into lower range, because this is the capacitor where the 12 volts comes. So we expect this to be 0. And then this is V-core. V-core has higher resistance. This is good. And what is this down there? Is this also 12 volts? Because currently I'm touching whatever was under the MOSFET, and this seems to be also 12 volts because it's connected to there. It might be something that is shorted though, and I'm kind of cautious about that. But let's see how this board now reacts when we attach power to it. Oh, it instantly turned on. Oh, something is burning hot. Oh, I think my adapter was burning right now. That is not nice. There might be something more shorted. That is not good. Is anything very hot on my adapter? No. Cannot feel anything getting hot on my adapter. Let's check the 24 pin here for resistances. We have on 5 volts we have kilo ohm. On 12 volts we have kilo ohms and rising. On 3.3 volts we have kilo ohms and rising. On 5 VSB we have kilo ohms. And on PS on we have also kilo ohms. So what's the problem then? Because our 12 volts... Oh, now our CPU 12 volts is shorted again. Yeah. So we still have a problem with that. Interestingly enough. That has now come up after we put power into it again. Because we first put power in. We had the blow up. We removed all of that. Measured again. Had no shorts anymore. Put power in again. Now we have a short again. So let's start with 1 volt and see what is shorted there. I didn't expect there to be more problems, to be honest. Because most of the time if we remove the whole phase, you're basically done with that. But we're going to go for 1 volt now. But 1 volt might be difficult to see in like 10 ohms that we had. So we probably will have to go for higher voltage. But let's try with 1 volt and see how it reacts. So putting 1 volt into there. With 1 volt we currently get nothing. Yep. We get nothing with 1 volt. So let's up this a little bit. Let's see, at 7 volts currently. I almost get... I do not get anything with 7 volts. Okay, let's go further. Let's go for 10 volts. But also nothing. Okay, let's go for 12 volts then. And see how this reacts with 12 volts in it. And also nothing. We get a very short power consumption, but nothing afterwards. Very interesting. Let's see at the backside of the board if anything has burned there. And before that, let's check the resistance again. But it says 0 ohms. And now it's charging up again. Yeah, and now we have high ohms again. This might be because of the burnt layers that we have such an inconsistency with every time that we put voltage on there. Because now you can see we have kilo ohms, over 10 kilo ohms, where we just had 0 ohms again. And let's see, do we have any burnings on the other side? But we do not. It definitely didn't burn through. Let's see. The board weirdly auto-started when the last time we put power on. So let's see if our P is on or our power button is shorted. So let's see. But no, it is not. We're probing the pin that carries the 3.3 volts from the power button, and it is not shorted. So it wouldn't be pulled down. Let's see, the regulator for the SIO, also high resistance. And checking some random capacitors around the SIO also reveals no problem. Weird that we had auto starting from this board. Nothing left but to try this again and see. So, who's ready for Flames Part 3? So, let's see. Instant startup again, 2 amps power consumption. Don't like that. I will have to be quick. I will have to get my thermal camera out and see where we have that 2 amps of power consumption and why this board is instantly turning on. So let's see. This area is still a little bit hot from when we were hot airing it, but I will be quickly now turning it on and off the power supply. And I want to see what is getting hot here. So we get something hot down here, but I don't think this is getting too hot. Let's see up here something. No. Don't really see anything that is like bad. But I smell burning. That is not good. Something is consuming a lot of amps. Let's try something. Let's see if we don't connect the 12 volts here, how this board reacts. So we still have 1.6 amps. And something must be getting really hot somewhere. But I cannot see it yet. So I think it might have blown my Pico adapter. Let's check that, if that is the problem or not. Yep. Ah, come on, man. This is the very first board I was trying to fix with this new adapter that I've modified. And it already blew up now because of a single main board. I cannot believe this. I will have to check what of this failed. Maybe there's a MOSFET that failed. Oh man, I cannot believe it. This thing was brand new. Like, this is the very first mainboard that I wanted to fix with this one, that I've modified to my needs. And on the very first board it just blew up because the 12 volts was shorted. Cannot believe that. Ah, well. let's see how this board now reacts to the power button, because now we have the board on with another adapter. And let's see now if it wants to blow up another adapter or not. So let's turn it on. And it instantly complains about RAM, because we do not have any RAM in here. This is very good to see. So let's get a cooler onto here. We have RAM now in here, and let's get also a post screen onto here. So let's now see. We have CPU. We have CPU turned off. So it cycles CPU again. Let's see, CPU again, a third time. Jumping amps, and now I would expect VGA. Third LED turns on, and there's our post screen. Oh, BIOS. Where's our BIOS? Did it restart? Think it restarted once more. Let's see, CPU LED restarting again. Let's see, do we actually just power cycle indefinitely, or do we get a BIOS screen? And there's our BIOS screen. Now the board is working. Very nice. Good to see. So the board is already mostly fixed. Right now, what we will have to do is to rebuild this face. And we will have to see why my adapter blew up. And what is shorted on there now. So let's have a quick look at this adapter first. I think it destroyed one of the MOSFETs on here. So let's go under the microscope and have a look at that. So we got a lot of flux on here. So I guess that this got very, very hot. Let's clean this up and let's measure this MOSFET if the MOSFET maybe died because of overcurrent. That it just drew too much and it blew it up. So the area cleaned up nicely. Let's get this into a board holder and then see. So let's see if this MOSFET is now shorted. So we get one probe on the top side and one on the bottom side. Yeah, and we do not get anything. Okay, let's see if anything is shorted to ground. Like if this coil that we see right here is shorted to ground. So it's not shorted to ground, and the other coil is also not. So we have 15 ohms on our 12 volts input. Okay. So we will have to go from the input side, because you can see this right here is our input side with black and red. And we have 15 ohms on our input. Let's see. Do we see if did anything here blow up? So I had it before that one of these diodes went short on the other one, either that one or that one, and it might have happened here again. This is just hot glue. This is not blown up. As you can see, this is just hot glue that I managed to get somewhere where I shouldn't have. So let's measure these diodes then. And this diode has higher resistance. Let's see for the other one. The other one has also higher resistance. So we will have to be putting in voltage into here. And we will have to find out what gets hot. So let's go in the overview again. So let's take our thermal camera. Plug this thing into its power supply. And let's just see something here. But that is the other side. Is that the other side of the board, or is that regulator? 100 degrees, something right there. Okay, it might be this side even. I see some small transistors there. Let's quickly once see on this side if anything on this side gets like really hot or not. No, on this side it doesn't get hot. So it is the other side. And I saw some small transistors on this side. That might be the cause of our problem. But of course they are directly under the wires that I soldered onto here to have PS on here. So let's desolder these cables on here that I have to get us a little bit better of a view. So the thermal camera was showing these two MOSFETs, or I think these are MOSFETs, some kind of transistors. These two, they're getting hot, and also this big one right here. So I will definitely have to get this big switch off of here in order for us to have a proper view and be able to repair this. So because it is hot glued on, I will be using hot air to take it off. So let me quickly do that first. So now we can have a better look. The button is now off. It seems to be that these two transistors blew up. So now I got all of the hot glue removed. Now we can see the transistors very well. So let's check these transistors. Just dumbly check them with continuity mode. So it isn't shorted. This one isn't shorted in these ways. Let's see. For this one. This one is also not, is it? It is shorted. So it is shorted from there to there. So I expect that this transistor here, it's probably an N-channel MOSFET, that this one is blown. Or it might be that this output, wherever this goes, is shorted. That it's this right here. Like that. It might even be really this transistor here. I think we have to unsolder this big transistor and see what this is for. Let's first, before unsoldering it, let's see if we can get a part number of it and look up on Google what this thing is supposed to be. So this is a D403 GA2C13. So let me have a look on Google what that is supposed to be. So what I was able to find is AOD403. This is a 34 volt P-channel MOSFET. What is its maximum amperage rating? Continuous drain current at 25. It's 70 amps. That is quite a P-channel MOSFET. Okay. So that might be blown. Let's desolder it and then see how it measures out of circuit. So I was able to remove it with minimal damage. And let's see now. Let's see. This to this is shorted. To this is shorted. So this middle one is shorted in all directions. And this is also shorted. Yeah. So this is shorted in all directions. So this thing is dead. So this one shorted to there, and these ones shorted between each other also. Yep. Okay, so this P-channel MOSFET is dead. Insane to believe that a P-channel MOSFET with 70 amps just burned through. Really insane. So let's see if there's still a short circuit then on our adapter. So we had the short circuit between there and there, and we still have something here. It might be that this one is also blown up. That there might be something more on here. So we will have to take this off as well to see if it's this rail here that is now shorted, or if it's this transistor here. So let's take that off. So this is now desoldered. Let's check these pads now. And they have no connection anymore. So it's not... So this wasn't shorted, but the transistor pretty sure was shorted. So let's get the transistor in view. So we have the transistor in view now, and this is a little bit harder. And there it is shorted. Yep. It's not shorted the other way around. So it's not shorted there and there, but it's shorted here and there. Not too sure. This might be the drain and source that is shorted here, if this is an N-channel MOSFET. So this thing is also dead. Let's see what this is. An A1-34C? Or is it A1I34C? Something like that. Let's see if I can find something in the internet about that. So the very good thing is, I have another one of these that is dead. As you can see, I've done something very wrong with this one. This one was my bad. I connected something very wrong on this one. And yeah, it looks like someone took a bite of it. But this one blew up really big. Like there was 12 volts shorted to ground with my 100 amp power supply and just burned completely through the board. But it means we have spare parts. We have a spare P-channel MOSFET and some spare of these, whatever these are. I'm pretty sure that these are N-channel MOSFETs. And we are just going to be taking these and going to be transplanting them onto the other one. And we will see if that will work then. So now on our original board right here, now we have the P-channel MOSFET soldered in again. And also this N-channel MOSFET. And let's now see how it will behave. So after having soldered in the components, let's now see how this thing behaves and if it's going to blow up again. So I'm very careful and the camera's rolling. Let's see. Nothing is getting insanely hot. 30 milliamps, 40 milliamps by itself. Power consumption. Yeah. This looks like it could actually work. So let's get the MSI board in here again. And let's see if it survives. So let's see. Passive power consumption. 130, just like we had before. Oh, I'm kind of scared. Let's hit this power button and see. 1 amp. And it seems to be booting. It seems to be working just fine. No smoke, nothing. Let me get the thermal camera. I just want to look if anything is getting hot on it. But the hottest spot is 34 degrees that I can see. 44 degrees, one of the controllers. This is very nice. Oh, we were lucky enough, so we were able to repair this thing with the spare parts of the other one. So we have 2 repairs at one. We have this mainboard blowing up my adapter, and we were able to fix the mainboard and the adapter. The adapter having a dead N-channel MOSFET and a dead P-channel MOSFET, and this one having a dead high-sat N-channel MOSFET, and now both are working, which is a great success. But we're not quite done yet. We still have to fix this phase right here of this MSI board to get it fully working. So let's go and take care of this as well. So now we are in our area where that we have to rebuild. And let's see. Let's scrape a little bit off of here. Let's make that way. To get most of the charring out of here. Like all of the burnt fiberglassing. Okay. And now, let's clean this up. It is very important that these steps to just constantly clean up in between. That we have good areas to work with. So now our area is mostly cleaned up. When I looked this up, This seemed to be also 12 volts, but let's use this for now. So what we need to do, we need to push this down a little bit. And let's free some of this up. This should be enough. And now we're going to clean the area again. And let's now see if these are actually the same. If this is the same 12 volts. So we're in continuity mode now. Let's see now. This seems to be the same 12 volts. Interesting. So it just loops around here. Because this is 0 ohms. This is the same 12 volts as here. So theoretically, what we could do is we could just connect this with this to have good amperage, and then just solder on our MOSFET onto here. Normally what I would do is like I would get some braid and cross it over and create a new pad with that braid and then solder it onto here. So let's do that. Let's get some solder onto here and here. So let's put solder onto here, because this is all one plane. And then let's put solder onto here. And I just like to use solder braid, actually. So this is just some used up solder braid that I have, that I used before. And what I do is I just cut a piece off of it. So this is still a little too big. Let's get that down a little bit more. And what we now can do is to solder part of it onto the top part and the other part down there. And let me try to do that. And what we have now is the solder braid bridged between this pad that we had right here and also the 12 volts coming in from here. And now we have a new pad where we can put our MOSFET on, and then we have to make sure that these are connected properly as well. So I found this board. This is one that we fixed before, a B450 mortar, and this is almost the same board as you can see. And we're going to be taking this whole VRM section from here. So one high side, two low side, and one controller, MOSFET driver. This board theoretically works. And what we will do to it doesn't make any, doesn't make it less, that it works less. But because there's still missing components on here. And this only works when you supply different voltages. Like you have to supply like 0.9 here and 1.8 volts here. In order to make this board work, or like to VPPM needs to be supplied here and 0.9 VDDP needs to be supplied, that this works. And I didn't want to order the controllers because they're really expensive. So yeah, this board theoretically works, but yeah, it also has rip traces here. So we're going to be taking this section of the VRM format. So I got the components now of the other board, and in preparation for this board, what I like to do is I like to add leaded solder to every single pad that we're going to solder to. So all of these contacts, all of these down here, all of this, then also here. Then we also add leaded solder to these pads. And also to all of where the controller goes. What I then do is then we take solder braid and we clean the whole area up. That we have no old solder anymore. That we have only new leaded solder on here. So we take all of this off. Then clear all of this up. And now the whole area is freed of the old solder. And what I now do is I just apply ever so slightly of just let it solder. Just to have some everywhere with a lower melting point. This will help it to make it way easier to solder to this board and lower the melting points of everything, having the need of less heat here. So now all the areas have solder on them. I will be adding some flux, and then I will be placing on our harvested components. So here you can see the harvested component PK632BA, 6 PK632BA. This is the low side, and the high side has the other one that that we also took off. So let's put on these ones first. So the components are placed, and I will be soldering them on now, and we will do the big high side MOSFET last, because this will be a little bit harder to do. So these two MOSFETs and the driver are now on, and let's see how well we will manage to put this on. This will be a little bit harder. So the easy part is going to be the big 12 volts part. The little bit harder is to get the output and the gate soldered on there. But we will try that, and let's see how well that will work. We will be trying to push down on it. So now it's basically where it needs to be. But I don't think that our output is connected properly. So I will be squeezing it as hard as I can down. So also that the that our heatsink later can sit properly on there. And let's try, as long as the board is hot, try to bridge our contacts as well as we can. So all of these are connected, these three, and this is our gate. Now it's connected like it should be. And let's see now, we need to check our resistances now. So let's see now. We need the 12 volts is supposed to be coming here, which it is. We can see 0 ohms. So, and now let's go on to ground. Our 12 volts is not shorted to ground, which is good. And now we need to check our gate. It is 6.3K to ground, and is it shorted to 12 volts? It is not shorted to 12 volts. This is our vCore output. Is it shorted? It is not shorted to 12 volts. Let's take the CPU out to see its resistance to ground then. And our output has a resistance of kilo ohms. There we are. Had a weird reading before, but 1.6 kilo ohms at the output. Okay, because as if you have a CPU in here, the output will read basically short circuit because of the resistance of the CPU. So you see this is like 200 ohms. It's probably even less. Let's go in the lower range. So the CPU reads 4 ohms, 4.8 ohms here. So before putting the heatsink on here and doing anything, let's see if this works now. So I'm kind of scared. I don't want to see another fire in this video. So let's have a close look at this area. So this is power up, and now let's press the power button. And it seems to just work. That is very good to see. So it boots up. That is very nice to see. But we will have to see if this face is working correctly. And we will have to look at the thermal with the thermal camera added. So now, having our thermal camera. And I can see something wrong, I'm pretty sure. Our driver is at 72 degrees. Which I think is not correct. Let's turn this off. And this might be because some of the passive components there might have burned up. So let's check that. I should have checked that before we do the first turn on. But let's see now. So our passive components that are important here are these resistors here. So let's check for their values. So let's see for this 2.2 ohm resistor. This reads good. Let's see for this resistor. This is maybe 10 kilo ohms, I think. Or something like that. Let me get in a higher reading. Almost 6k ohms. This is supposed to be 0 right here. And this is almost 0. Let's see to be exact. Yeah, this has 0 ohms. This is very good. And there's one more resistor that we have up here. This has 6 ohms. So let's go into board view and check what these resistors are supposed to have for a value. So we have our board view, and this is supposed to be a 10k ohm resistor. This is supposed to be 0 ohm. This is supposed to be 5.1 ohm. So I think we're fine with our resistor values in 2.2 ohm. So just to be sure, I want to check that 10k ohm just once more. 5k ohm, but that is in circuit with the CPU attached to it. And the 5.1 is a little bit higher. Yeah, 5. So all of the resistors are fine. Very interesting. Let's see. I want to put the heatsink onto here, and I want to see if this board can withhold a stress test. And we need to put that capacitor on there as well. Let's do that quickly. Now the capacitor is back in here, and I will be now trying to put this back onto here. So now the board is fully built up, and the heatsink is on there. I've checked the 12 volt resistance, and we're not shorted. And what we will be doing now, we will be booting this thing into Windows, and we will be trying to run a stress test on here. And we will see if this VRM survives. So I will be letting the camera roll. I probably won't even be at it. But let's see if this lowest phase will blow up or not. So we have gotten all the way into Windows. And now it's going to be the interesting thing to be running a stress test on this board. So let me arrange it a little bit differently. So we still can see this area where we reworked the VRM area. So we will be running LinPack on here, and we will be stressing this VRM for quite some time. So now LinPack is going to be running here, and I will be taking a little step back from here, and I will be just letting this heat up and be stress testing it, and we will see if it will blow up or it will survive. So see you whenever either the test is finished or the board has blown up. So the board is still running, and it's still looking very good. I will check with my thermal camera And you can see the exact track where we have reworked. And I believe if I see that correctly, it says 82 degrees. No, it's lower even. It's 70 degrees. Yep. 63, 65. So, that looks very fine from what I can see. It definitely does heat up more than all of the other phases. But this is under heavy full load. 60 degrees. So this should be fine. And yeah. The performance is also just like I would expect. So a very, very interesting and special repair. One where not only the board itself blew up, but also my adapter blew up. And we were able to repair both. And having quite some spare components, quite some dead components now here. So we have a small transistor and a big PMOS transistor blown on the 24-pin adapter, and then we have the two low-side MOSFETs, one high-side MOSFET. These are probably fine, but I just wanted to change them out to be sure, and also the MOSFET driver that you always need to change as soon as the VRM blows up on a mainboard. And yeah, I'm very happy for this repair that all worked out at the end and that I was able to show you that. And yeah, hope you enjoyed the video. All of my tools are linked in the video description. Thank you very much for watching. This was Mainboard Medic. Thank you very much and goodbye.